Here's your lesson today for math. You're going to be able to learn to identify and evaluate expressions. This is your first lesson of this chapter, so let's get it started off on a big high note. Today's date and page number should also be in your notebook. Alright, here's your warm-up, a little order of operations practice. Now something we haven't really looked at yet, just to make an identification to you. Number 3, you see it says 6 parentheses 9 plus 2 plus 7. Whenever you see a number right next to the parentheses, that means multiplication. So make sure that you know that this is 6 times 9 plus 2 plus 7. Good luck, and come back when you are ready to show me that you know your order of operations. So here are the answers you should have got. For number 1, the first thing you have to do is 7 times 3, which gives you 21. Then from there it's 4 plus 21 minus 1, 24. For number 2, the first thing you should have done was 15 divided by 5, and I got 3. 87 minus 3, 84. For number 3, the first thing you do is the parentheses. 9 plus 2, which is 11. And then you're going to do 6 times 11, which is 66, plus 7, 73. And finally, number 4, you go left to right. So 35 divided by 7 is 5. Then you do 5 times 5, and you get 25. If you got all 4 of those right, I want you to give yourself a pat on the back. All right, let's start to talk about what variables are and what an expression is, and make sure you understand these properly going forward with this unit. So on the left-hand side, I wrote 3 different expressions. 4 plus 6, 4 times 3, and 75 divided by 5. I'm going to want you to pause the video, and I want you to tell me, and write in your notes, why these are not equations and they are expressions. Alright, now I want you to look at x plus 6, y times 3, and z divided by 5. These are also expressions, but we don't call them regular expressions, we call them algebraic expressions. Take a second to pause the video and answer why. I'll give you the answers. Alright, so the reason why the top 3 are expressions are because they have no equal sign next to them. They're just phrases. Okay? 4 plus 6, 4 times 3, 75 divided by 5. These are all things you've seen so far this year. The reason they're not equations, no equal sign. So why not? No equal sign. Alright, x plus 6, y times 3, and z divided by 5, they are also expressions because they have no equal sign. But we don't call them, but we call them algebraic expressions because they are using what are called variables. And on the next slide, I'll have some definitions for you to write down. So one of the things that you could be looking at when you're trying to do input-output or these algebraic expressions variables could be this thought of inflation. Inflation is the rise in prices that occurs over time. So back when your parents were your age, they probably said, man, things did not cost what they do today, which is true. For example, in 2000, when I was a sophomore in high school, you would have paid $7 for something that back in 1950, which is my grandpa's time period, would have only cost $1. So with this information, you can usually convert prices to figure out how much it was. So we make a nice table here. And the one thing you can see is if we set it for 1950 as $1, in 2000 it was $7. So in 1950, $2 would have been $14. And 1950, $3 would have been 21. So what did you do here to get to 7? What did you do to 2 to get to 14? And 3 to get to 21? Well, your math facts are good and strong, and I know that you noticed that what you had to do was you had to take the money, which we represent with P, or $sign P, and you multiplied it by 7. So what we do is we create an algebraic expression that says No matter what money you give us from 1950, we can figure it out in 2000. So if I said to you, um, or my grandpa said to me, back in 1950, I bought a brand new Buick, and that Buick cost me $2,000. All right, we can figure out that in 2000, all we have to do is take this $P. That's what we're dropping in there. All we got to do is multiply it by 7. And now you would say, if I bought that same Buick in 2000, that would have cost me $14,000. Okay? So it's a way for us to try to express values and try to figure out what's missing by using the information we already see. So we're going to get moving on. There's really no other notes you have to write down on here. I think the most important thing, obviously, is the questions you answered and this table. And if you didn't put it in, that's fine. Clear the board. Here we go. All right, so we have two definitions I do want you to write down. And they're things that I talked about already. First one is being a variable. So a variable is a letter or symbol that represents the quantity that can change. So in the table that we just did, it says above, or on the last slide, I kind of cut it up. P is a variable, and it stands for any price in 1950. You can use any symbol you want at any time. There's no specific need for a specific symbol. In science, you'll see that we have specific symbols that mean things. But if you're just creating something on your own, you can create whatever you want. Now, there is a second part to that. There was the variable, and then there's the constant. And the constant is a quantity that does not change. So in our example, we knew that from 1950 to 2000, everything was always going to be 7 times higher than it was in 1950. So that's a constant. We know it's going to be the same. So have these written down because these are words you're going to hear me use as we work through the lesson. A couple other words you'll hear me talk about, and we already kind of introduced this a few minutes ago in the video. Maybe a minute ago, 2 minutes ago, I don't know. An algebraic expression. That's your next vocabulary word. So what this does is it contains one or more variables and may contain operation symbols. I do put the bracket all the way over here because I want you to have the example. P times X is an algebraic expression. We have our variable P, we have our constant 7, so it's an algebraic expression. Now, one of the words we used in the last chapter to know that when you want to solve something was simplify. The other word you're normally going to see is evaluate. Okay? If you ever see in a problem that says to evaluate for an algebraic expression, you have to substitute a number for the variable and find out what it means. So you have to answer it. So the other thing I have up here for you to look at is, nice check mark, what an algebraic expression looks like and what an algebraic expression does not look like. So on the left-hand side, 150 plus y, that's an algebraic expression. 35 times w plus z is also an algebraic expression. 85 divided by 5 is not an algebraic expression. These are just expressions. Okay? They have no variables. So it's a lot of the stuff we saw in our first chapter. Have this written down before moving on. Most importantly, the two definitions. Now the last thing you can choose to write down or not. Now when we work with expressions or working with equations, anything going forward, I want you to be aware that there's more than one way that we're going to write multiplication or division. Excuse me, big yawn. You couldn't see it, but it was big. So when you look at x times 3 on the left, it looks like xx3. That gets very confusing. So you usually are going to see it x with the period or the dot in between, x times 3 with parentheses, which was in your warm-up, or the most common one is they write 3x. So anytime you have a number and then, which is your constant, and a variable next to it, that's going to be the most common way, 3x. Division, we also write it as fractions. Very commonly we write it as fractions, so start to get used to that. You might have even seen some of these in your pretest that look like this as well. So whenever we have it written as 3x, Basically, we do it that way so it identifies the constant first and then the variable, and you always just call it as 3x or 3 times x or whatever variable you have there. We could have a q there, 3 times q. All right. Now let's get into some actual practice. So here's our first practice, and of course you wrote practice or are writing practice in your notes. Here we're just going to evaluate algebraic expressions. Now sometimes you'll be given a table like this, and it'll say evaluate the expression. That means we got to find out what in the world is missing. So in this table, we see that 16 is what y is going to represent for this scenario. So if we have that, this is what I like to call plug and chug. All we got to do is put 16 in for y, and 5 times 16 gives you 80. Next, we have 27. What are we supposed to do with that? You plug and chug. Really what that's saying is, what is 5 times 27? And 5 times 27 is a big number, but remember we can use the distributive method to look at it as 5 times 20, which is 100, and 5 times 7, which is 35. 135 gives you 135. Okay. Now the next one is 35 in our variable column. Again, we just have to plug that in for y. So 5 times 35 is really what we're looking at. And again, 5 times 3 is 15. We just add a 0. That's 150. And 5 times 5 is 25. So 150 plus 25 is 175. Now, let's see if I am correct. If I tap the screen, you'll see the answers show up there. So it shouldn't be too hard. You look at the column, you see where the variable is, you put that value into the expression. By evaluating that value, you can find out how much it's worth. You probably want to write this one down in your notes. You don't have to probably write all the stuff in blue, but for sure the table and the work that I did in the table. Once you have that done, we'll move on. Okay, let's do another one. This one's a little trickier because you have to do a couple steps. You're still going to have to use order of operations. It doesn't disappear. So in this scenario, to evaluate the expression, we have to find out that the variable z, we already have values, 20, 45, and 60. So all you then have to do is plug that 20 into z, 45 into z, 60 into z, and see what you get. Well, for number 1, or the first row, when we put 20 in for z, the first thing we have to do for all of them is 4 squared, which is 16. Okay. Then you can do 20 divided by 5, which is 4. 4 plus 16 is 20. Now, since we're using the same expression every single time, what I like to do when I have a scenario like this, and I know with order of operations I have to do 4 squared first, I always rewrite it, getting rid of that first challenge so it's not as difficult. Now it's just a little easier to look at. So for the second one, we're going to put 45 in for z. We're going to divide by 5 and then add 16. 45 divided by 5 is 9. 16 plus 9 is 25. We'll see if I got that right in just a second. And then with 60, again, all we do is we put 60 in for z. So you keep replacing whatever variable it is with the number that we see in the box. We'll divide that by 5 and then add 16. Now 5 goes into 60 12 times, and then all we have to do is add 16 to it, and we get 28. Now, if I'm right, the answers will show up behind this white box. Oh, look, I was right. So 25 and 28 are your answers. Okay. Now, the reason I put it over in blue here is just so it looks a little neater, a little organized, because I was doing all my work there. All right, your choice if you want to write that one down or not. You don't have to. We're going to move on. All right, most commonly, you'll use this whole idea of expressions when you're trying to figure out lengths, dimensions. You'll see this a lot in science. So if we had a rectangle that we knew was 4 units wide, inches, feet, centimeters, it really doesn't matter. How many square units does the rectangle cover if it is a 3, 4, or 5, or 6 units long? All right, so in our scenario, it told us that every single one of our answers is going to have 4 for width. Okay? But it also told us that the length may change. And it gave us 3, 4, 5, or 6. So you make a table showing your length of 3, length of 4, length of 5, length of 6. Width is the same all the way across. And now we know, looking at the expression L times W, which has 2 variables, all we have to do is plug the numbers in that we are given and chug out an answer. So 3 times 4 gives you 12. 4 times 4 gives you 16. 12 square units, 16 square units. We'll see if I'm right in a little bit. 5 times 4, that's 20. You should know your math facts by now on the 4s. And 6 times 4, that's 24 square units. The other reason why I wrote it in the blue here is so you can see the proper label. Was I right? I certainly was. The rectangles will cover 12, 16, 20, or 24 square units, depending on its size. So the nice thing is now, if someone gave you a rectangle and they said the width is 4 and the length is 3, 4, 5, or 6, you already know what the value is going to be. I do want you to write this one down as an example because this one shows us 2 variables that have to be plug and chugged. All right, your big box of thought today. I want you to try to name a quantity that is a variable and a quantity that is a constant. I basically want you to give me an algebraic expression. So use a variable and use a constant. That's a letter and a number. Wink, wink. All right, number 2, explain why 45 plus x is an algebraic expression. Why is that considered an algebraic expression? A hint to you, if you need to go back to the notes, watch that part again where I talk about the difference between an algebraic expression and just a regular expression. All right, now that you got your box of thought done, let's go to the quiz. Your quiz shouldn't be too hard here. It's 2 questions. I give you the tables. You have to make the tables in your notes and fill in the answers. So for number 1, you're evaluating for this expression x squared minus 5. So just replace for that expression 3 times. 10 for x, 7 for x, and 5 for x. And the bottom one says a rectangle is 6 units wide. What is the area of a rectangle? What is the area the rectangle covers if the length is changed from 2, 3, 4, or 5? Make your box. Should be easy to fill in. All right, I'll be waiting for you to show me your quiz. We'll see you next time.